Today's question: if 1 mole of monoatomic gas having gamma, this is gamma, not G, so gamma is our adiabatic index, is mixed with 1 mole of diatomic gas having a gamma, that is adiabatic index 7.5, the value of gamma, that is adiabatic index for the mixture is. So we have to find out the adiabatic index of the mixture when 1 mole of monoatomic gas is mixed with 1 mole of diatomic gas. So in this case, we are going to use the formula which is based on the degree of the freedom as well as number of moles of each gas. So we start with the basic, that to calculate the effective adiabatic index, effective gamma, that is our adiabatic index, for a mixture formula based on the degree of freedom and number of moles of each gas will be used. Formula based on degree of freedom and number of moles of each gas will be used. And the standard formula for gamma, that is our adiabatic index, we have adiabatic index which is given as gamma is our Cp upon Cv, where Cp is the molar specific heat at constant pressure, and Cv is the molar specific heat at constant volume. So here Cp is our molar specific heat at constant pressure, and Cv is our molar specific heat at constant volume. Molar specific heat at constant volume. Therefore, for a mixture, the total heat capacities are weighted average of number of moles for each component. So we can say for a mixture, the total heat capacities are the weighted average based on number of moles of each component. Based on number of moles of each component So this can be written as CV for our mixture MIX will be equal to N1 multiplied by CV for monoatomic plus N2 CV for diatomic. And similarly, we can write that for at constant pressure for mixture will be equal to N1 constant pressure for monoatomic plus N2 constant pressure for diatomic. And the effective adiabatic index which we can call as gamma mix will be equal to constant pressure mixture divided by constant volume for the mixture. Now let us calculate the respective CP mix and CV mix, and for that we are going to use the degree of freedom and heat capacities. Degree of freedom and heat capacities. So we can write first of all for monoatomic gamma mono, it is given as 5/3. So therefore we can write that constant volume mono will be given as R divided by gamma mono minus 1, and this comes as R divided by 5/3 minus 1, and this will be equal to 3R/2. Similarly, we can find out our CP mono now. We know that CP plus CV is equal to R, so therefore CP minus CV will be equal to R. So we use that formula. So we get CP mono will be equal to CV mono plus R, and we substitute here, we get this as 3R/2 plus R, and this gives us 5R/2. Similarly, we calculate for diatomic. Gamma for diatomic is given as 7/5, and we can say similarly that our CV for diatomic will be equal to R gamma diatomic minus 1. So this comes R 7/5 minus 1, and this comes as our 5R divided by 2. Now we can find out our CP diatomic. This will be equal to CV diatomic plus R, and this comes as 5R/2 plus R, and we get this as 7R/2. So we found out our values: CP for diatomic, CV for diatomic, as well as CV for monoatomic and CV for diatomic. Now we find out the total heat capacity of the mixture. total heat capacity of mixture, and keeping in mind both are 1 mole, therefore we can say our N1 will be equal to N2 and will be equal to N1, because for 1 mole. So we substitute the values, and we already have written the formula. So let us call this as equation 1. So we use equation 1. Using equation 1, we get that our CV of mix will be equal to 1 multiplied by 3R by 2 plus 1 multiplied by 5R by 2, and this comes as our 8R by 2, and which is equal to 4R. And similarly we write our CP mix will be equal to 1 multiplied by 5R by 2 plus 1 multiplied by 7R by 2. This comes as 12R by 2, and ultimately giving us a 6R. So we got all the values, and we know that the effective adiabatic index, effective gamma, that is our, we have written it as if gamma effective will be equal to Cp for the mixture and Cv for the mixture, and this is our Cp is our 6R and 4R. So we write 6R upon 4R. Here R and R cancels out, and this comes 2 and this comes 3. Therefore we get that adiabatic effective is our 3 by 2. So this is the effective adiabatic index for the mixture. This is the effective adiabatic index for the mixture, and the options that are given to us, if we check them, we can say that okay, it is fraction, it is in decimal, so obviously it will be 1.50 because it is 3 by 2. So option number B is the correct option. So we can write this is equal to 1.50. So we can say option B is the correct one. Option B is correct. So this completes the question. Thank you.